The title of this tutorial is DC sweep analysis. We will employ the same simple voltage divider circuit used in a couple of other DC tutorials. With this voltage divider that we have on the screen, we are going to go to the DC sweep analysis feature. Now, as discussed in another tutorial, I will make use of the particular icon here known as grapher. And so if I click on grapher and look at all the various options, I'll go down here to DC sweep and click on it. Now, the DC sweep window opens, and you have the choice. If you have more than one source, you have a choice of which source that you want to sweep. There is only one source in this particular circuit, so of necessity it's listed up at the top, and the bottom part of this is not meaningful for this particular run. Now, you have a start value and a stop value and an increment. I don't recall if these were the original values or not, but it doesn't matter. I'm going to choose to sweep from -15 up to +15 in volts, of course, V being on the right. And while this will be a linear straight line equation, just to make a point, I'm going to change the increment here. It comes out as 0.5 volts. I'm going to change it to 0.1 volts. If you have a non-linear characteristic, you could go down to a much smaller type of increment, but 0.1 will be fine for this purpose. Now, we're going to be sweeping V source, so let me make a point here before I go any further. The original circuit that appeared in a previous tutorial was set at 18 volts. You can leave this at whatever value you want, because when you do a sweep, it is this window that sets the values for the sweep, which in this case will be from -15 to +15. So this value here has no relationship whatsoever. It's the values you set on the sweep window. Now let's go back and locate that in the middle just for the sake of discussion. Now we have to specify the output variable. This is the one that is sweep, the V source. Again, if there were more than one DC source in the circuit, you could have separate runs with each one sweep, or you can have a family of curves within a set of curves. We won't get into that right now. But output, it was set apparently at I of R1. I'm going to remove that. Instead, I want to look at V out. That's the voltage across the resistor on the right hand side. So I click on it and then add it in. And so now I've set the output variable V out, and I'm sweeping the source voltage V source. So I will come down here and click on simulate. And immediately the curve comes up on the screen. As was the case with other runs, we can change that to a light background if you so desire by clicking on graph and clicking on black and white colors. I'll go back to the default one, which is the black background. Now let's look at some of the labels that come up on the curve. The file name, which I haven't even mentioned yet, the file name that I established in Multisim was voltage divider. So this top line here is the name of the file. This is called a DC transfer characteristic, so that is automatically comes up, although you can actually change that if you desire. Along the horizontal, we are sweeping V source, so you see V source here, and it's measured in voltages. It is a voltage and measured in volts. Along the vertical axis, we are looking at the particular variable, which is indicated down here as V out, V of out. If there were more than one variable that we wanted to sweep, you would see two or more colors on the screen. I might show that a little later in the demonstration. Now, as the curve shows here, it's kind of hard to read because you would have to use a little bit of imagination. But let's just go right up here to something called Show Grid and click on it, and we immediately have a grid on the screen, making it a lot easier to read variables on the screen. There are numerous features up here, that some of which probably I've never used all the features, I don't think. But at any rate, let's take a look at this curve and see what we have and see if it's making any sense. This is a linear circuit, so the output voltage should be linearly proportional to the input voltage. If we have 0 source voltage, we have 0 output voltage. If you have, let's say, 5 input voltage, you have 5/3. Remember, the transfer characteristic here is 1/3. You get 1/3 of the output voltage. So that variable, we would have to stop and read what that is. I won't take the time to do that. But over at the extreme here, for 15 volts in, you have 5 volts out. You have exactly 1/3. And the slope of this curve all the way from beginning to end is plus 1/3, because of the fact that it is a simple voltage divider. Now, some of the things that can be done, let me illustrate the use of cursors. If I left click on this, I have a little window that opens up down here showing various variables, and you have 2 cursors showing up here. Now, one of these is denoted as cursor 2 and one is denoted as cursor 1. Let me just move cursor 2. If you hold down the left button on the mouse, you can move the cursor over. I'm going to move it over to the right hand side and get it out of the way and concentrate a bit on cursor number 1. Well, cursor number 1, if you look down at the graph here, it says you have x1 and y1. It doesn't matter what your variables are, it's going to show up as x and y, x horizontal and y vertical. So for cursor 1, we have x1 as minus 15, corresponding to the very left-hand side, and y1 as being minus 5. On the other hand, x2 has been set at plus 15, and y2 comes out as 5. So as I move either of these cursor, if I put the pointer on it and move it, for example, let's take this point here. This is a point of minus 10. It's showing up as minus 10.0098, but that's minus 10 for all practical purposes. You can fiddle around with this, but often if you have a finite step size, you may not be able to get it exactly where you want to. This is a function of how small the step size is. So we can go back and make a much smaller step size and probably locate this with more accuracy. But at any rate, this is about minus 10, and we're seeing about minus 3.33 as we would expect. And of course, if you need to move cursor 2, you can do the same thing, but it really shows up pretty much the same way as cursor 1. Now you have a dx. This dx here is the difference in the x variables between cursor 2 and cursor 1. So we have cursor 1 sitting at minus 10 for x, and cursor 2 at plus 15. So 15 minus a minus 10 is 25. So that's dx, and dy is the value change between y2 and y1, which can be readily checked. I won't bother doing that, but it can be readily checked. Then you have dy dx. Now that would be meaningless for such a large value in change if this weren't a straight line, but because this is a straight line equation, that dy dx is the slope, which in this case is 1/3, 0.333. But if you had a nonlinear characteristic, you can locate the 2 cursors close together and get a better estimate of what the derivative might be at a given region by looking at the change in y divided by the change of x. Probably, strictly speaking, in mathematical terms, that ought to be called delta y over delta x, but this is fine for the purpose intended. And finally, you have the reciprocal of dx, the reciprocal of the change in x. Okay, that shows a little bit of what the cursors do. Let's just get the cursors out of the way here and go back. I can click back up here on cursors. Now, I will make a point here that there are many different operations you can do with these curves, and I'm only showing a few here. If you wanted to copy this and put it in Word, you could go here to Edit and click on Copy Graph, and that would copy the graph, and then you could paste it into a program such as Word. And finally, I want to show how to change some of the characteristics of the curve itself. If you click, well, it's a right click, I guess. Okay, took me a little bit there. I needed to use the right click on the mouse. Sorry about that. Just goes to show that there are so many little fine points, you will forget them from time to time. But when I right click on the graph, this window opens up and you can do all kinds of things. I'm only going to show a few things here. For example, on the traces, this is the width of this trace is 1. If suppose I want to change that to a wider width, I moved that up to 3 and clicked OK. And notice the curve comes out of somewhat bolder in this particular case. You can go back to such things as relabeling the left axis if you desire, relabeling the bottom axis. If you needed to use the right axis or the top axis, you can do that. The top axis is up here. That can be relabeled. So there are a lot of different things that can be done with the graph. You can change the scale, you can change the range. There are just many things, and the only way to learn this is to experiment. And I'll be honest with you, I would have to experiment myself to even figure out some of these things because I haven't used them necessarily all that often. Some of them you can change a number of ticks on the screen. There are just so many things to do, but we'll leave it at that. I think we're getting close to the end. So I'm just going to terminate this particular run at this point. Again, this is the DC sweep analysis, which is a tool to be used to provide a sweep of a DC source voltage.